You guys ever hear the story of the undergraduate student that went on an observing run and almost broke a multi-million-dollar telescope, and it somehow ended up being a good thing? No? Well, you're about to. Oh, what up, space nerds? So it's been almost a year since part one, either because I'm terrible at editing or because astronomy takes a long time. I foolishly choose to blame astronomy, but either way, it took me so damn long to put this video out that I was able to take the class again and go on another observing run to Kitt Peak.
It's been 84 years.
So, silver lining, I guess. But across the two trips, we observed both star-forming regions in colliding galaxies and exoplanet transits using the Bach 2.3 meter telescope, or as literally everyone calls it, the 90-inch. So, what exactly were we doing out there? This class was designed to teach us how to do an observing run from start to finish. We picked our targets, we learned how to use the instruments, and we collected all the data ourselves. And then we figured out what all of that meant. Or in normal words, we learned how to use the telescope, we picked cool things to look at, and then looked at it through big expensive CE thingies. And after the big mirror gave us all this data to look at, after way too much processing, it turned into this, which honestly looks significantly more sciencey. Then we stood in front of our professors and tried to convince them that we knew what the hell we were talking about. We learned how to use the instruments and find our targets in the last video, which both my professors and I realized I could have explained a lot better, so another unexpected benefit of me taking forever to finish this video is that I get to explain it like a big boy scientist, but more on that later. It's amazing and slightly surprising how similar the two trips felt. I was just as excited getting on the bus, I was just as excited pulling onto the mountain, but my perspective was completely different. This time, I was a peer mentor, which arguably was a mistake on everyone's part. People actually came to me with questions now, which was weird because in my head, I'm still the guy walking around not knowing what the hell is going on. But not knowing what is going on, that I can mentor people on. To the surprise of no one, that was one of my best qualities that I could bring to the table. My best qualification, if you will, because I remembered exactly what it felt like. Every single person on that first trip hit a point where nothing made sense. Every single one. And then, little by little, it started to make sense. It started to click. So whenever someone looked overwhelmed, I could honestly tell them, yeah, it's normal. Don't worry about it. Kitt Peak is a national observatory 7,000 feet above sea level. So take that, Denver, and your mile-high stadium. I'm sorry, Denver, that was a completely unnecessary drive-by. This fantastic observatory sits on Tohono O'odham land. And it's awesome because the people who set it up did what they should have and actually went to the natives first to ask permission and show them what they'd be doing by bringing telescopes and allowing them to look at them. Side note, the natives called them the men with the long eyes, which is the most badass way I've ever heard. There are over 20 telescopes on this mountain covering so many different types of observations. And this beast over here is the Mile 4 meter telescope, which you might be more familiar with if I tell you this is where DESI is located. That huge project studying dark energy for the better part of the decade, that's where it is. And this is what it looks like on the inside. This telescope is the size of a school bus, and that is not an exaggeration. It is actually as big as a school bus. This control room is for DESI, and DESI alone. Obviously, that's not the one that we're going to be using. The spray can looking one over here was ours. Welcome to the 90-inch Bach telescope. And welcome to the late 1960s when this was born. And I swear the first time I saw this, I was like, they just look at Apollo 13 and just replicate everything in there? And then I realized, no, it's kind of the other way around, isn't it? But don't let the size fool you, the 2.3 meters compared to the 4 meter earlier. This bad boy has been collecting data since 1968, not because it wasn't replaced, but because it is still doing exactly what we need it to do. Also, if you think astronomy has unlimited funding, I present you with Exhibit A. Now, all of it isn't from the 1960s. In fact, we were the first group to use one of the new instruments. So yes, an undergraduate astronomy class technically commissioned a new instrument on a professional research telescope, which feels like that's something they should have thought through a little bit more, considering, I was in that group.
60% of the time, it works every time.
And now we wait. Kind of needed to be dark if you plan on looking at the stars. So we just walked around the mountain like kids in a candy store. Then we got our dinner at 3:30 in the afternoon, and then went to pick up our night lunch, which is just astronomy at its finest right there. So we picked up our sandwiches and burritos and whatever else we were going to hide out in the fridge in the control room until after midnight. Then, as the sun set and night fell upon the outside world, and all those other sciences with their daytime experiments lay their brilliant minds to bed, that's when we shine. The night belongs to us.
Jesus.
Okay, now it's time to space nerd out on some exoplanets. I mentioned earlier that we were the first group to use the new 90 prime instrument, and our TA said it should have been called the 90 double prime. We all agreed, and that's for all of my math nerds out there. Now, I hear you say, okay, wannabe space dude, what the hell is the new 90 prime instrument? And that's a great question. Well done, Internet. And that is something I never thought I would ever say. To answer your question, the new 90 prime is a CCD, or a charged couple device. It's already a terrible start in explaining things. So first, here's a technical version, if I can see. Charged couple device is a semiconductor detector made of silicon. When photons strike the silicon, they can free electrons through the photoelectric effect. The number of electrons generated is proportional to the amount of light that hit each pixel. After the exposure of those electrons are shifted across the chip, the charged coupled part, to be measured, converted into digital numbers, and ultimately assembled into an image. Alright, that's the physics. Now let's space dude this out a little. Alright, so basically, photons hit the silicon detector. The energy from the light knocks those electrons loose, and each pixel acts like a tiny little bucket collecting them. The more light, the more electrons, the better the picture. Camera companies have built an entire industry around this concept. So the detector counts the electrons, converts it to digital numbers, and the computer builds an image. Congratulations, we turned light into homework and then into awesomeness. Little side note, one of the girls on the trip saw this happening and she's like, light is so friggin' weird, I love it. Shout out to you, Maya, that is observational astronomy in a nutshell. We used the new 90 prime to check out Kepler 17b, an exoplanet orbiting, you guessed it, Kepler 17. Now this is a hot Jupiter, which for once in astronomy is exactly what it sounds like. Imagine Jupiter, now imagine it was yeeted inside the orbit of Mercury. It's giant, gaseous, and ridiculously close to its star. But that's not the crazy part or even why we picked that target. We chose that target because it orbits its star every day and a half. Mercury orbits the sun faster than any other planet in our solar system, and it takes it 88 days. 88 days. Our time on the mountain was 4.5 days, I think, which is 3 years on Kepler 17b. I celebrated my birthday during this trip, and this big-ass gas dude over here is celebrating 3.
I'm not even mad. That's amazing.
Dude, focus.
Right. Okay. So, how do you see a planet that's too small, too dim, and way too far away to actually see? We don't. We cheat.
If you're not cheating, you're not trying.
We see what light that planet steals from its star. Every time Kepler 17b passes in front of its star, it blocks out just a tiny bit of light. Not a lot, so you need a sensitive telescope. Which we have. Earth's atmosphere is annoying. Twinkle Twinkle Little Star is basically a threat to astronomers because twinkle just means Earth's atmosphere is taking perfectly good light and smearing it all over the place. So we need a way to see if the star is actually getting dimmer or if it was our atmosphere being rude and childish. So enter comparison star. So here is Kepler, and here is innocent bystander we're going to put under surveillance for aiding and abetting. Let's skip ahead through all the sleepless delirium and boredom that is waiting to click every few minutes to get the data, and we now have this. It still doesn't look complete, but if you combine the graphs from group 1 and group 2, you get this. A light curve of another friggin' world orbiting a star like 2,600 light years away. The light had already been traveling through space for 350 years before Hannibal even started dragging elephants over the Alps. That doesn't look anything like the graph you showed 5 seconds ago, space nerd. Not done. We divide one star's data by the other, and suddenly the Earth's atmosphere mostly disappears. But in that night, we commissioned a brand new instrument on a professional telescope and verified the transit of an exoplanet.
I don't know how to put this, but I'm kind of a big deal.
The second part of the observing run involved changing the instrument. Like, we literally helped change the instrument, take the other one off, put this one on. And surprisingly enough, this isn't when I almost broke the telescope, which we'll get to a little bit later in the night. So with the new instrument, we go from seeing how bright light is to figuring out what it is made of. Meet the other main character, ARP-269. 2 galaxies that have made some questionable life choices. They're colliding, but not like head-on. More like one galaxy had a little too close of a drive-by and gravity just started stealing stuff. And those long streams stretching? Those are called tidal tails. Gravity is stealing gas and stars out of galaxies.
Strategically transfers equipment to an alternate location.
And that gas collapses to make even more stars. So galaxies are weird like that. A group of stars start ripping each other apart. And the universe is like, you know what this needs, bro? More stars. Which brings us to these little pink blobs. H2 regions are basically giant neon signs that say, hear ye, stars being born here. Wow.
How are we the same person? How?
And unlike CCDs, the B and C spectrograph takes that light and rips it apart. Every element leaves behind its own fingerprint. Hydrogen, oxygen, sulfur, nitrogen, Neil. Neil! You're still not getting an element named after you, Neil. And those fingerprints don't just tell us what those elements are. Oh no, we interrogate them. And we interrogate them until they tell us what the hell is going on under that gas. And hydrogen is one of our biggest clues. When we see a strong hydrogen emission line, it usually means young, hot stars are pumping energy into the gas around them. So basically it means baby stars. Now, there's a little more to it, and we also calculate something called metallicity, which to astrophysicists and the absolute horror of chemists is anything heavier than helium. Again, to Maya, I am sorry. Okay, so after all that nerding out and infuriating chemists, we can finally answer the question, are those tidal tails forming stars? Yep. Both of those regions we observed landed right where we'd expect active star formation to be, which these blobs aren't just pretty, they're stellar nurseries, places where entirely new stars are being born. Awesome! There's another awesome thing about the Bach telescope. It has an eyepiece, so you can physically look out into space. Most big telescopes don't have that. See, this was from the first trip, Saturn and 4 of its moons. The second trip went a little differently. You see, there are 2 eyepieces on the Bach telescope, and we did not know that. So when my professor asked me to go look through the eyepiece, I went up to look through the wrong one. And I accidentally bumped something, and that something was a coolant hose that leaked all over another cooling part for the spectrograph. So this guy broke the telescope yesterday.
Yeah, I saw the whole thing. You're not gonna bring up the fact that it was intentional?
I didn't do it intentionally.
No, you took like the tubes and you gnawed at it like a beaver. It was really weird to watch.
I was hungry.
Yeah, thirsty for coolant apparently.
So our chances of doing any spectroscopy that night were 0. So I thought I ruined the entire trip for everyone. Thought we wouldn't be able to use the whole telescope, but it turned out it was kind of a gift for us. It's that second piece, the one that I thought I broke, was being taken off the next week. They didn't even need it anymore. And that night was the only night clear enough for us to do the eyepiece viewing. So that was awesome. And to keep this from happening again, we wrote the manual for eyepiece viewing on the Bach telescope. And I don't mean that like exaggerating or anything like that. We literally wrote a manual on how to use the eyepiece properly, how to have the right mechanics and the right settings to get proper seeing. And you conveniently forgot to mention that after you broke the eyepiece, you sat in the corner like a little baby and refused to look through the eyepiece anymore. Sleep deprivation, a hell of a drug. But I mean, looking back, that's kind of what this whole trip was. We commissioned a brand new instrument on a professional telescope, which I still can't believe. We observed the transit of an exoplanet, and we found evidence of star-forming regions inside 2 colliding galaxies. I almost broke a telescope, and somehow ended up writing the manual for how to do it in the future. Well, we did. I didn't. And all during a time that we're normally passed out sleeping. That's astronomy. Most of the time you're just trying not to screw things up. But every once in a while, you accidentally leave the place a little bit better than you left it. I said left it, didn't I? Then you found it. Wow, I'm a mess. You see how I do? Anyway, that's about all I got for you guys. Bye-bye.
Wanna be a space dude. I was born a space dude.